Hi all, welcome to another session of ST Skills System Design. And today we are going to solve a problem together, which is design, logging, and monitor system. Okay. So yeah, we can all have a chat and can start together. So anybody has a question like what is design, logging and monitoring system?
Is it something like from a let's say from a application from a let's say I have an app or something, uh, uh, SDK basically, and from
Uh,
which we need to monitor logs for the application.
so I think let's make it something like where let's put some requirements. So basically, a centralized place to store logs. It could be, I could think like example could be Splunk. So basically, a place where all your services can send their logs, a centralized place. Has anybody used Splunk or some other tool similar to that?
Log4j. Similar
Log?
Log4j is library.
No, we are not talking about the library. We are talking about the place where we can do storage and do analysis.
I mean log DNA.
Like a New Relic?
Yeah, New Relic log DNA, something like that. Yeah.
Is New Relic a place for analyzing logs also?
No, that's I think
It's
a monitoring one.
monitoring tool. It's more
Yeah.
like a,
It's a monitoring tool.
Elasticsearch, the Elastic one is something like Splunk.
Yeah, so Splunk is a full-fledged solution, right?
Splunk is actually for log analyzer, right? It's not about the log monitoring.
No, you can do monitoring also. So Splunk gives this all kind of alarms, charts. So based on your logs, you can create charts and alarms and a lot of other things.
Yeah,
Okay.
we can create dashboards. We can do create alerts from that, and we can even monitor using Splunk. Yeah.
Mm-hmm.
I use Splunk in my project. Yeah.
Mm-hmm.
There's one called SumoLogic that's specifically for logging, though you can set up dashboards and monitoring as well. The
Mm-hmm.
way that I've used New Relic, it's a little bit more different. New Relic sort of monitors the hosts and alerts on, I think, high throughput, like unusual traffic. They have some new
Uh-huh.
APIs now.
That
So why not split this into two parts? I don't think so. We
Yeah.
can solve both of them together. There are two different things. One is design logging, and the other one is monitoring system, right?
you want to pick up one of them for today or both of them?
I think we can only take one, but if
I would say that, I mean, whoever proposed this, I mean, let's let him drive the requirement.
Yeah, I
Okay.
propose. I was mainly going towards monitoring.
Okay, yeah, so you drive the requirement.
Yeah, primarily this was a question asked to me way long ago in an interview, asking about
Uh-huh.
designing a system that can analyze and monitor logs. So you should have a way to monitor logs, as in like the way you told about alerts and bells. Like if anything goes wrong beyond a threshold, then the user group in associated with that rule should be alerted. The latency was it was live data was the one that was told to me. So when the live data logs goes beyond or below a certain threshold, then the associated user group should be notified of this break in change.
So basically, so basically, is I think it's Shri Prasad, right?
Yeah.
So Shri Prasad, so is it right that the logging system is already there? So I don't need to bother about that.
The logging system is already there, is what I am also assuming. But there should be a way to like consume that streaming logs from that logging system onto your analyzer. So my thought was like the monitoring system should be like baked to the logging system as well. You can't have like two separate logging system and then another monitoring system.
So what is actually we are monitoring here?
The logs for any kind of exception or any kind of latency changes.
Okay, so it's not about the CPU uses, hard disk uses.
It could be anything, but there could be different categories. So basically, it could be something like if some value is greater than, let's say, something like if you can set your rules. If the value is greater than 70%, what is that? Where is the percent? Yeah, for 5 minutes, last 5 minutes, then raise the alarm. And for let's say 10 points, 10 data points. So basically there could be rules, custom rules. You can say like, okay, for this log, let's say the log is something like, let's say the log is something CPU, and the value is something like 60, and so this is parameter. This is what I'm understanding, and the val is 60. So if for last 5 minutes, if the value is greater than 70, let's say here, and for 10 data points, we can even define our data points. That means I have to take some action, and that action could be
So who will produce this value? So some client on the box or what?
In this case, I don't think so we have to care. We are just giving like this, these are the rules to create. Wherever the rules will, wherever the logs will come, we'll analyze it and take action. That's it, my understanding.
Yes, you don't have to worry about who produces it. There are clients and systems which are producing these logs, and you just have to build the monitoring on those logs.
From the application side, like the logs are coming continuously streaming, and on our side, like on the system design side, we need to first store them, and then I guess like we need to analyze them and then send in notifications or something.
Yeah, without storing them, how will you? My understanding, I don't know, but I think without storing them, how will you know whether the 10 data points have got or 20 data points have got? To analyze that in 5 minutes, 70 value is only 60, and our rule is only saying 70. So without storing those logs on our system, I don't know any other way that we can analyze that. Based on the
I'll just give how we do logging and monitoring in our application using Splunk. We do post the application data. So there are two types of data: application data as well as systems data. System data will have all these metrics like CPU, memory, and all those things. So we post both to the Splunk servers. And Splunk will have a retention period. They have, let's say, 30 days or 90 days, based on the capacity. It can store the logs for certain number of days. It can store for certain number of days, and using that Splunk's details, we like Splunk logs, we create alerts like application errors versus application errors and CPU and other monitoring stuff too. That's how we do. Yeah.
So what's the differentiation here between logs and metrics? So like my understanding is Like
Yeah,
this,
it's just a logs. Yeah, it's just a logs, but from that log, so it matters what you are trying to get, what data you are trying to get from that log. So system logs will have only these things, like what is the CPU, current CPU, like at this moment, what is the current memory, what is a load average, all these things. So it will have all these data, but the application logs will have so what is the request, what's the status of the request, so all these things.
but you can create. So are you going? So to create alerts, are you first going to create metrics out of those logs and then create alerts on those metrics? Like, because like logs, see, logs could be like, if I am getting any exception, I am logging the exception, right? That is
No,
a
it's
log.
not just exception, like it's not like logging. When you see exception, you're just pushing data each, like in an interval, like every minute or every 5 minutes or
What
every
is
2
that
minutes,
data?
whatever.
What is that data that you're pushing?
Yeah.
That's what I'm telling, right? It's
So
system
one
data.
example I can give that in one of my previous company, we have microservices based architecture where one service is first getting a data from another service. So we share a unique ID between the individual services. And finally, every service log the data, and the data goes to the logging server. And then we have a monitoring system. Basically, the job of monitoring server system is to collecting, aggregating all those logs data and to present a nice dashboard where you can see that which particular microservice is getting more load, or how the performance of a particular microservice, how much time throughput it has. So it is easy to do the backtracking also. So there are a number of use cases you can achieve by having a monitoring and logging system. One is performance, one is exception tracking. So multiple things you can do. Yeah, that's what my understanding about these two systems.
Okay, so I need to do some kind of orchestration and moderation here now, because we're still here at the requirements phase. And so in my understanding, these two systems can live together or even can live separately, but that's what we have to design. And here I would say I would take I will go with how so Shri Prasad can tell us like how the interviewer approached him, and we can follow the same thing.
So
Otherwise, we will be solving so many problems together.
yeah, basically this is the same thing. What my interviewer told me, having a logging and monitoring system that can analyze real-time data and alert the user if the rules that has been specified is.
So basically, you got two things: logging and monitoring, both, right?
Yes.
Okay, let's go with that: logging and monitoring system, correct? That can create actions. And so basically we have to do kind of both things. We have to store the logs also and analyze the logs also.
Yep.
Okay, let's get some requirements then. So store logs, analyze logs, and monitor.
The user should be able to create or edit the threshold and actions.
Yeah, rules and actions.
Yeah.
Custom rules, and this is everywhere these days. If anybody has used Elasticsearch Kibana, they also provide this functionality now. And what else? We can, yeah. What else?
It's live data, live streaming data. I don't know whether that makes difference.
Okay, live logs coming. What else? store and I'll say, I don't know if this is more, it will make complex, but store and view logs. You can even view your logs. Yeah.
Exceptions, errors, and exception and errors that can
No.
come
Mhm.
in logs.
That comes
Yeah,
in.
anything can come in log. We don't care like what is coming in the log. You can send exceptions, metrics, whatever, and then can create analyzers, monitors, and custom rules and actions. Does it make sense?
Yeah.
Okay.
And it has to give real-time alerts, right? Looks like that's a major requirement also.
Yes. So see, action is whatever action the user will take. So I can put this like this should be real time. Okay, let me put that near real time. There is in distributed system difficult to say real time. Okay, so what else? I think we have these requirements right now. And then we can build. Shri Prasad, what do you think?
Yeah, this is what I also ended up. I did not have the one thing which I did not have was the view logs part. I only had written store part, but you had written view logs also. But that's the only difference which I've seen.
Okay, we'll see if we can cover that. Otherwise, that's fine. Okay, and let's have. Okay, what could be our non-functional one?
Availability.
Yeah, so availability is fine. We can have eventual consistency here.
Number of days the logs should be stored. Let's say the log have arrived today. So
30
for
days.
how many days that log in the history should remain? For 30 days, 20 days, how many days?
Retention
So-
period is 30 days.
So let's say our retention policy is we to get started. Let's say like it's 30 days. We'll only have logs of last 30 days, or even we can make it. Some companies even have like really less than that, like 14 days.
A message, or in this case, a log should not be lost once it's there. So durability.
Yeah, durability is needed. What else? What do you have proposed, Shri Prasad?
Yeah, these are the three ones which I told them. Other than that, I did not have. I also wrote consistency, but it's the same thing as durability.
No, we also put eventual consistency.
Yeah. Okay. Yeah.
Anything else you have mentioned? And the interview is okay with that?
The interview was okay. I then moved on to capacity planning.
Okay, so that is interesting here. The outcome part.
So we're designing a log pipeline, not a metric one.
This is the metric. We have custom rules and live logs and actions. I didn't get what you mean by log pipeline.
Okay, so logs, metrics, and traces are three different things, right? They need to be processed in a different way.
Right. So the way I understand, basically, you have real-time logs coming into the system, and you need to.
Are you guys hearing an echo?
Yeah.
No, I think I can't hear them.
Same for me.
Okay. Are you hearing the echo now also?
No.
Okay. So, yeah, there are some questions, but I couldn't understand what was the question.
Yeah, so I was asking, like, if we're designing a log pipeline or a metric pipeline.
So can you elaborate some differences?
So with logs, the application servers are basically writing log statements to a file. So it's kind of structured logs, like so they have like dimensions and other properties like key value pairs basically. And with metrics, they're logging a single metric, let's say saying that the metric name is CPU, and then it will have a couple dimensions, but it will have a single value. And then metrics could be of different types like counters, gauges, timers. So monitors, like both of them serve different purposes. So logs are basically just for analyzing like what's going wrong with my application. How do I investigate like the current state of the application? And metrics are different. Metrics are basically just like data points that application servers can push, and then I can aggregate them and raise alerts based on that. So if I'm more focused on real-time detection of issues, like mostly for like operational insights, then I'll use metrics. And otherwise I'll use logs, and they'll have very different pipelines. There are very different tools that you collect data for logs versus metrics.
Yeah, and also to add to this, like logs could be converted to metrics. So like basically metrics are those fixed numerical kind of values, right? Based on which you can see those real-time values and you can create alerts. But let's say if I have log, let's say I'm logging that this is the exception, right? I can create a metric out of it, which could be the count of this particular kind of exception. So then basically I'm taking my logs, I'm writing some code which is processing those logs and creating metrics out of them. And on those metrics, I can create alerts. So in this case, let's say if my exception was like system IO exception, then I can write that logic that count all the system IO exception in last 1 minute and then get the value. So now this value is my metric. And on this value, I can create an alert that if this system.io exception, which was logged, if its value is more than 100 in last 1 hour, then I can create an alert. So, but basically like, as you have mentioned, like metrics are more about creating alerts. Like you have those numbers through which you can create alerts. And now logs actually help you debug once you have those alerts. Like once I have an alert that there is something wrong, then I will need to go and look back at the logs to actually debug what has gone wrong with my system.
Right. So that's what I'm trying to understand. Like, so what are we designing here? The logging pipeline or the metric pipeline?
So the question was like this only when they asked me. I was thinking that this is kind of a system where which can accept any kind of log, and log can be system log or any application log. And the way the system and application log comes in, we can analyze that logs to determine, hey, within this X amount of time frame, if it fails or passes a rule that was put in, like for a threshold, for example, then it would alert a set of users. I didn't differentiate between whether this was a metrics-based system or it was a logging only log-based system.
I see. Okay. So then that would be the first question probably worth asking, that what goal are we optimizing for? Are we optimizing for like real-time detection of issues or anomalies, or it's fine if we wait for like a minute and then basically aggregate data within that minute and raise alerts?
No, that part was answered. It's a live logs. That's a requirement number 4.
Okay, if it's live logs, okay.
No, but live logs, but processing time is also live, right? Then
yeah, it should be near real time.
I see. Okay, then from the logs we need to generate metrics. So again, I mean, probably worth asking questions. We can pick one approach probably. Then it's fine.
Absolutely.
We can go with logs.
Okay, cool. So right now, let's get to the logs. I think worth asking questions like gives a good impression on the interviewer that you know things in that direction. But again, it's a 45-minute interview. Interview could not come and ask you to solve all the problems together.
Right. Yeah. So we need to pick one. So I think whichever way I'm picking is fine, but it's good to have that interaction upfront.
Okay, nice. So let's pick up logs only for now, and we can.
For capacity planning, like I asked like how big is your application, and I am assuming that this is only one application that we are logging, and not like multiple applications, like for multiple companies. And for that, he answered that assume that this is a application that supports 100 million users. So how much will be the log that is generated? And I basically said it's probably between 10 GB per hour. That's one number that I threw out. Like 10 GB per hour is the log that can be generated. Different types of logs. It's not.
Go ahead. Sorry, complete your thought.
The different types of logs. It's not like I didn't specify just application log. I said, okay, maybe 10 GB whole application for all the nodes, for all the different logs that is emitted. That is the roll number. I just threw out a number. Not sure whether that's right.
Okay, but I think the question could be, see, the log payload would be very small. It could be in few, I think, bytes or KBs. I think the question which I would ask is how many times it will hit my service. So basically, how many times I will get the request. So in a minute or a second or a day.
But
and
I thought that was configurable, right? Isn't that configurable?
See, let's say there are 10 services and they're hitting, every service is sending logs like 1 million requests per second, let's say. That means 10 services make me like 10 into 1 million, right?
10%.
So basically, let's say I have 100 services and new services can add, and one service send calls or whatever, like whoever is a caller. I'm just taking services and they are making like, let's say like 10K logs request. I'm taking a higher number per second. Okay. So this means like, and then we can even say average payload could be like, let's say 100 KB.
Uh, 100 KB average payload is like per second, or the payload size?
Payload size. So every request have an average of 100 KB payload.
That's probably a lot. I'll pick less than 1 KB, I'd say.
Okay, let's take 1 KB, right? So that can define like how much data we are getting per second, per day, and per month types of setting.
Yeah, and the app may not be used for a long time as well, right? So 100 million users, I'll maybe another way to look at it could be per user, I'm getting, let's say, X number of requests per day. So I can assume, let's say, each user is making 10 requests or 100 requests, any number we can pick. And then for each request, I know how much logs would be generated. For each request, let's say 1 KB of logs are generated, then I can calculate. I don't care like when it happens, when it doesn't happen, but I get the aggregate for the capacity. And then I can include the peak load as well. Like what happens when there are too many logs, like I can calculate those two numbers. One is like the total logs generated and the peak logs generated at any peak time.
So basically you're trying to calculate the upper limit of the total number of payload or logs that can come into the system that we're designing, and that you're differentiating to the case where the normal day and when there is a peak in the application traffic. Is that right?
Not really. So it depends on the retention policy. I see you've written it as 14 days, But generally, like we don't really persist like full logs like after 14 days. So after 14 days, maybe I'll need less logs, like maybe just the aggregated ones, or maybe even 14. So that's probably a question for the interviewer. So this retention policy means we are retaining full logs for those 14 days or just aggregated ones?
No, full logs. You can go and search in the logs.
Okay, full logs for 14 days. Then yeah, we just calculate the daily logs generated, and that should be it for storage. Yeah, for storage, I think that should be it. Yeah, so 1 KB is average payload, and you mentioned 10K. 10K logs requests per second probably doesn't matter because per second, again, it can be used for peak metric calculation, but not for total log computation. So I'd say 100 services, and like I'll take the total number of requests. I'm getting for 100 million users, I'm getting, let's say, 1 billion requests entirely. Then for each request, I'm using 1 KB of logs. Then
so you mean like whenever the user log there, because let's say I'm a user, I will do some operation. That operation can result in 10 logging calls.
Right.
So you're just saying like, okay, let's say like whatever happens, 100 million users could result into 1 billion requests to log service.
Right. Yeah, so I'm assuming the requests generate the logs, but otherwise there are not many logs generated. And I can calculate number of requests based on number of users and the average number of requests per user.
But your logging application should be idempotent of that, right? Like I can change my application at any point of time to add more logs. Your system should be able to handle it. So how would we be able to say that earlier enough that 1 billion requests to logs only will be coming? Like I can change my application at any point of time to add more logs.
Right. Yeah, but here we are doing capacity planning. Like we are trying to compute how much storage we need. So for that, I'm probably this much data should be enough.
Just to add to that, I think at the end of the day, the logging system doesn't care how many users the systems have. It just matters how many logs are generated. So I would go with point 2 with how we have a per second assumption of how many logs are generated versus saying 100 million users and 1 billion requests, because that could vary a lot day by day.
Yeah.
And you want to do an upper bound like someone else mentioned, and you want to basically cap your storage capacity to a limit. And then, so I don't know if average requests really helps in capacity planning. That's my thought.
Okay, so let's go with this for now to have a calculation. Like 100 services, 10K logs per seconds, and it would easily give us like how much things we are doing in per day, per second setup, and yeah. So do you want to spend more time or shall we proceed further?
We can proceed. I think we have enough data.
Okay, and I was also thinking like these systems could be another requirement, but we can think about that later. It's like a rate limiting thing. So like if there is a client who is who started misusing the system or went rogue, so it could limit that users. Okay, you slow down or something like that.
Yeah, I didn't think about this, but yeah, there could be a system which generates more logs and clog the whole metrics pipeline. Or
so to give a fair share to everybody, we can have some kind of a rate limiting.
But let's say a user is using application, and while he's using, he's getting some errors due to which the logs are being failed. It should be sent to the developer that these are logs coming from a particular user. Like, should we limit that?
Not particular. This is per service.
Okay.
Anyway, there is action, right? So if the exceptions or whatever goes beyond that threshold, then anyway it is going to be actioned upon and alerted upon. So if it's like a threshold is like 100 per second and you are getting like 200 per second, then it is way beyond the threshold. Then after that, if you get 500 per second, 600 per second, it does not matter. It is above 100.
Or it could be alerting for this design logging and monitoring team, like when, or you might not limit them, but you might get alert like this service is abusing the system, take some action, and then you can reach out to that team and say, or create a sev1 ticket for that team, like why I'm getting so much logs, where it's coming way beyond than what was agreed.
Yeah, and it's a very nice way of saying, in our company, they just blacklist the app.
And this question is probably for the interviewer then.
Yeah, it's mostly for the interview, but it's more in terms. I think now that this discussion is going in that direction, like where you can kind of now impress the interviewer, like, okay, you have thought about this, or basically it's like you have similar things in the past.
Yeah, it's definitely a point of failure.
So yeah, so basically, I think these are really good points where you might not create that system, but you can talk about them and say like, okay, this could be a V2. We are not taking right now, or you just chat to them. Like, do you think like a rate limiter right now, or we can take in the next thing? Or for example, here also, do you want the view part right now? The interview will say, okay, this could come later also. Let's put that as a V2 and have store logs as V1 and other things also V1. So I think it's a good way to put together like what requirements you are thinking and what you are trying to solve right now.
Sure.
So what exactly do we rate limit? The requests that are coming from the user, or the generation of logs, or the publishing of logs?
Generation of a log from an entity. Entity could be a service or whatever application.
I see. So generation we can't change, right? Because the service is running. We have no control over the service.
So that's what we are telling them. Like if you start abusing, we'll cut you down.
So we'll stop the service altogether?
No, it won't stop. We will just reject their request. And if they have a bad logic on their side, where the logging request is reject and shut down their service, so that is a bad design on their side. And I have seen this situation in the past where one of our thing, suddenly the logging system stopped working some reason, and the application also start responding slow because it was waiting for it was waiting in a synchronous thread, the response back from the logging system. And because there were some retrials, because of the application went slow. So if application is waiting on things on the logging system, that's a bad design on the application side. That's what I'm trying to say.
Yeah. So
right. Yeah. So
fire and forget.
Yeah, it's mostly fire and forget for most of the logging system that I worked on. Like there is no way that we can get a response every time we send a log to a different entity. It's primarily fire and forget. And I think we have enough requirements at this point.
Okay.
So one question for my understanding. So are these logs directly, like you call the API of the logging service to upload the log, or first you log these logs locally on the disk, and then from the disk, they are constantly uploaded to this service?
That's good question. Yeah, so there could be a bulk upload or a direct service call. And generally, I have seen like system gives like something like an agent. Splunk provides an agent which you can install, and then it could and aggregate and send a bulk thing together. So we can do either way, but either way it would be something. Yeah, I think when the agents upload, they have a different protocol they follow.
One question I have is like when you do a batch upload, like you hold on to the logs for some time and then an agent uploads them in bulk, what happens to the liveliness of the data? Like you want to have live logs coming, right? Wouldn't
See,
that
again, if you're making a REST call, it would take its own sweet time. There would be connection open, server request response. Here, what we are saying, you store it on the system. Few things it would do optimization there itself on your side only. I think it does some optimizations or clean up things and then bulk upload. So few things it will take care before it reach to the system.
I mean, if your batch upload time is like between 2 seconds or 1 second, maybe, but I don't know. REST is not going to take that much time, right? Like you are just sending a request with the payload of 1 KB or maximum average size is 1 KB. So it should not take like much time, right?
So there would be a couple of other things, handshake. Here, I think they follow a different protocol with the agent. Agent will always have a open connection with the server, and immediately when you put that on the file system, it will wait for like some milliseconds, take all the things and bulk upload. And that process seems to be really quick because it is followed by a lot of applications.
Yeah, I think to add to what Asim's saying, I've seen that paradigm used more often than having an API call, because the rest of your microservices should be blind to logging event happening. And by having this agent just sitting on your host and only doing this one thing, I think that's the way I've seen it done too.
Can
Because
you
whose
and I think
responsibility is it then to make that API call, open the connection, send the API request, and all of that stuff? Not the microservices.
Yeah, I have seen most of the services, they do this. Somebody mentioned in the start, log4j. So there are libraries like log4j. You tell like put it in this location, and from there it will get picked up by the other guy. For example, it could be CloudWatch or some Splunk or something.
So
I think Siri Prasad concern is it should be live, but to answer here, I think the agent will be as much as fast than like as much as fast like REST API. So it won't be making any big difference in terms of live data.
So can you
like in one of the application, what we do, like whenever we get some log, we store it in a system and then send it. But when there's a crash, so application is not live at that point. So whenever the user open, we compile it and store it in a system. And when the user restarts the application, also at that point we send the log of the last crash.
Okay, so can you tell me, like, I did not get this point. You are opening a connection and then sending. So is it like a WebSocket connection? If it's not,
No,
like,
it's not. It's let's say you are using some application. Let's say it's a Zoom application, and now from the Zoom you're getting some crash or something. Then it's sending over it's sending to the place where all the logs are getting stored. But let's say when the Zoom crashed, at that point your file that have been stored is stored in the system. But when you reconnect the Zoom, the last crash log would be sent over.
yeah, that part I understand. My question is about the protocol for communication.
Uh,
That is it REST-based protocol, or is it like a TCP, or like what is it that you are using so that you are communicating this batch files of data that you've stored somewhere to the application that we are building? I don't know the answer to this question.
Actually, in like I don't know, but what we do, like we from when the system, like the application restarts, we the crash logs are being zipped, and that zip file is thrown to the S3 bucket, and then the whole process, like 30-day attention and all the stuff that happens.
Okay, so that's one possibility, that you can upload this data to S3, and then you can create folders on S3 every second maybe, and then pull the data. This application can pull the data from that location and then destroy the location immediately. I don't know whether that's the right approach, but that may be a possibility, that you upload it to S3. Now the question is, what happens if the upload fails? Those are questions I have no answers to. TCP port open, which directly, I don't know whether you can just upload a file directly via TCP to a different location outside, but that would enable, like, you don't have to open a connection every time you want to send a file. It's an open connection that is open always. until the client dies. And then you just, when the client comes back up, it creates another open TCP connection and then send it. So the connection handshaking part is now gone away. It's only one time that you do. And then it just stream these logs to that location. That was the other approach I was thinking. S3 approach, maybe it works also. What do other guys think?
So basically the discussion is, do we need an agent or not? So agent would be collecting logs, doing some compression and sending it to the some location. It could be S3 or a stream or a REST service. So I think that was a point of discussion. And now it could be a design part, how when you get data, where you want to store it. You want to put that in some kind of streaming environment, or put that in a object-based storage like S3, or do some other stuff. So
Yeah,
I think design part now.
Yeah, correct. That's a design question. Yeah.
But I think we can assume for now, like there is already an agent. You just put that and it will aggregate and send it. Once the logs comes towards us, it could be one single entity or batch. We don't care, and then what will happen? And that's what I think we can now proceed in terms of designing it.
Sure.
Any other questions or comments from the folks?
So the we have two approaches here, right? One is the application server directly pushes the log to the backend, like New Relic or Splunk, like via REST call. So that means that the application is tightly coupled to the backend. So that's why we use an agent. Pretty much every product I've seen, they use some kind of agent, like FluentD, CollectD, Scribe, or which basically looks at changes in files. So the application server is writing to a file system. It's creating one new file like every X minutes, and the agent is basically using a file system utility. Let's say on Linux it would be iNotify to get notifications of file changes and within a specific log directory. And once it knows, okay, this file has changed, it starts aggregating those logs and like formatting them in the way that the backend understands. So if my backend is New Relic, it will have a different format of logs that it will expect in the logs to be in. Like it won't be just JSON. Like every backend has their own accepted input format. So this agent is basically not just like just sending logs one by one. It's basically detecting changes in the log files. It's aggregating that data like over a period of time. It's not like making one request over the network like per log entry. It's basically collecting a batch of logs.
So it's batching, and even it is doing compression and so many other things.
Right. Yeah. Yeah. So it's transforming it into the format, doing that compression, and then sending that request to the backend. And the application server is just using like TCP or UDP to directly push. But then again, that's a tightly coupled approach. So in this approach, it works much better, because now you just need to configure the agent, and there might be multiple processes running on the same host, and they will the same agent is able to handle and process logs for all of those services.
And then the application is kind of agnostic to logging system. So if I remove Splunk and put some other X here, I don't have to change my application. Application will keep on sending to that location, and this agent will take care of what it has to do next.
Right. And if the agent goes down, the apps are still running.
Yeah, apps are still running, yeah. But this kind of setup works well when you have application server. But what if I have a website?
Yeah, it still works pretty well.
No, then we are asking all our users to have agent installed on their computer. Website want to make a direct logging calls to the server.
So website is hosted on our servers, right? Not on the clients.
So basically, okay, so website could be hosted on the server. It could be a single page application, right? And it could be, but the entire now application JavaScript is running on the client browser.
Right.
So that kind of interaction, I think we want something like a REST-based calling system.
Right. Yeah. Client side is a different problem altogether, because they'll be making REST calls and we are processing those REST calls and enqueuing the message to a queue, and then aggregating from that, let's say, Kafka
that
queue.
could be another, or put them in some kind of stream and then process it.
Right.
If it's a website, you can't even store it somewhere else to later for the agent to pick it up. So it's there's only REST way I can think of.
Yes.
So yeah, so good discussion. Like we actually come up with
one point here. So one disadvantage we have discussed of this logging locally and then uploading is that it might not be as fast as directly making REST calls. And if we need real-time metrics and all, then it might be slow. So is this kind of system used for real-time monitoring system as well, or like?
So this is near real-time monitoring. So the agent is generally configured for a duration like 5 seconds. Like every 5 seconds, it's going to aggregate whatever logs it has. Maybe it got 1,000 log statements in those 5 seconds. Then it's going to send them in a single REST request to the backend service.
Okay.
My question is like, why not put that rules aggregation like on the application, so that like you are anyway putting the logs in the application at some place. Why not have that agent that is finding the log?
It would be too much work for the agent. So think like you're running this in a container, right? You have limited resources. Your application is running, and next to that, the agent is running. And now agent, we are adding a lot of responsibility. It will eat the CPU and memory of the container. And then your application could starve for resources.
Okay, makes sense.
So yeah, so that's one of the non-functional requirements, that the logging agent is basically not using too much memory. Like it's basically using less memory and less network bandwidth, and not affecting the resources that the app has available.
Yeah, because otherwise everything is now Docker images and running on containers. It would like, and what you're talking, if I have multiple instance running, agent could be on all of them, or it could be another pattern called Sidecar. Like,
right,
your agent would be running in a side container and talking to all containers. It's again like how you configure your agent and talk to the services, but it would end up using your resources, and more computation, more analysis means like agent will take more resources from your side.
Right. The sidecar approach is generally preferred. Like, so there's one instance per node rather than per container. And we need one instance per container if we have way too many logs. Let's say we are generating millions of logs per second. Then we need to and if we cannot store every single log statement because we are generating so many logs, then we need to do aggregation on the each container before actually pushing logs to another server that does the aggregation.
Okay, good discussion. Abhishek, you are having a question. Okay, somebody chimed in.
I was asking like, what is the approach that you draw on the left-hand side top? Like, what is that approach?
None of them, because this is just discussing how regular we train. If I have to design, I won't care about how the agent will work. It's just agent would send logs, and my part will start once I got the logs. I won't care like how agent is configured and doing his job.
But agent is part of your system, right?
No, if that's what I'm telling. Like if I go too much into this, then I would only end up creating an agent. We have to be really careful. What is the core part interviewers is looking? Interviewers might not be looking for how agent will work, because agent is something we told interviewer, and then interviewer got interested to know your thoughts, like this conversation. But the core, like what is the heart of this thing? Like, you got a request.
I see your point. Yeah, it's a rapid hole. Yeah.
Yeah, you got a request. This is your logging system, right? It would give you a view functionality. It will give you like an aggregation, and then something like an alert. This is our core part. How agent, REST, and these all things is like a side discussion. good to have. But if you don't solve this, then all the discussion would not help to crack the interviewer. Does it make sense?
Yeah, yeah.
So you have to be careful in terms of like go towards the crux, the core heart of the problem. So interview at the end when interview is doing this feedback submission, their interview can mention, oh, the user, the candidate mentioned about these things, but able to solve this entire problem. Okay, so any other questions, shall or we proceed further?
Yeah, let's proceed.
Okay. Clear everything. Okay, so 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 we are getting logs and okay, so Shri, I would put you on a spot. So what you did, you can tell me, and I can start from there.
So I had basically one load balancer, which will be accepting the requests from clients.
Okay.
Once the load balancer, then it will pass through a system, which will first put it directly to a messaging system, message pipeline Kafka or something like that, which would first persist it to a DB. On the other side of the Kafka, you have a DB which you are persisting the logs for every request that comes in. And then I had another system which reads from the DB and then does the monitoring or monitoring part. So that will aggregate like how many logs that you got per like based on the rules. So you'll have like a rules DB where you have put all your rules. The service will read from that rules DB once and then look at the message DB that the Kafka put in and then analyze whether there is a mismatch, like if you have gone above or below the threshold. If it has gone above or below the threshold, then it will put in a messaging system which will alert the users based on whatever registered devices that they have registered with. That was the primary design that I had.
Okay. Okay. So, okay, let's discuss about this then. What I drew looks good. Like that's what was your thought process?
I didn't get that question. Were you asking me something?
Yeah, I drew something here. If you're able to see.
Yeah. So you put from the load balancer to Kafka. Kafka writes to the DB. Then you have another service which is called a monitoring service, which will read from the rules DB and put it in some cache so that you don't have to go to a rules DB again, and then read the data from the message DB based on the rules, and then I wrote a messaging after the monitoring service finds a mismatch and puts that message to be like sent to different registered devices for this system. So in your case, you don't have that second Kafka. That's the only difference.
Okay. Let's, yeah.
Quick question about the rules DB. What rules are we storing in there exactly?
That rules are like if the message is greater than like 70% of the threshold, then send a message, send a alert. So for example, if you see a exception, say unauthorized permission denied exception or something like that, and if you see that permission denied exception happening for more than 10 times in 1 second, then send an alert. That is one rule. So if the rules DB has such a rule, then the monitoring system will match that rule against the logs that the Kafka put in the logs DB. And then if there is a violation, then the monitoring service will send a alert. Did I answer your question?
Yes, thank you.
Okay,
And
so
You don't want to go to read the rules DB every time. So I had some cache so that I was thinking that the rules won't change like quite often. So I had put the rules in one cache, and there is another service which like syncs the rules DB and the cache after every 10 minutes or something.
We have a question in the chat. Why do we need Kafka here?
No, that is a messaging broker. We can use anything.
Yeah, you can. It just has to AMQP protocol has to be the any messaging system.
But Kafka do not guarantee order delivery in case of more than one partition. Yeah, how many partitions do we have? Will we have in Kafka for one particular topic?
That depends on what is your topic. In my case, I had identified as a topic as a unique client ID and a unique server's ID combination. And I'm saying those two.
Sorry for interruption, but Kafka do not suitable for bigger than 1,000 topic, and you can have more than 1,000 topic, yeah? And Kafka will, how to put it?
You can have multiple clusters then.
Multiple clusters. And what about message size for Kafka?
We discussed of 1 KB, so it should be good for Kafka.
Okay.
And
yes,
we
so,
are doing aggregation also. Yeah.
Yeah, here we don't care about the ordering of the log messages. So they're fine if they are in different orders and they're going to different partitions.
And they have a timestamp, so we can play around with that up and down.
Yeah, and then logs, I'm guessing they would be persisted in a time series database, like not just a regular SQL or NoSQL database.
Mm-hmm. So let's talk, let me drop this and we can now make an alternate design to this. So what I was thinking, if I have to do, there would be this, there could be this service which is accepting logs, putting somewhere, and then there would be this kind of admin service which is talking to this, let's say, rules DB. So we can have a get and post request for creating new rules and get the rules and other things. So basically another separation here. And then there is this entity. Let's say everything which lands first, we put that in some kind of a Kafka, and then we can make it distributed. And now we have to read this data in some other service. So what we'll do here? So one suggestion I heard, kind of put them in some time series database, or can I say like I can directly put that in Elasticsearch and use some components like logs, cache. I'm not familiar with that, but I was reading like we can use Elasticsearch for storing incoming log. Basically, Elasticsearch is meant for that only, but we can say, okay, I will directly use Elasticsearch.
Yeah, yes, we could do that. So the Kafka queue would be the input source for the log stash. Log stash will do the aggregation, and it will persist that output in the time series, or basically Elasticsearch in your case.
So why do you need that service between Kafka and Logstash, I mean Elasticsearch?
Someone needs to do the aggregation, right?
So aggregation done by Elasticsearch, right? Why like there is a SVC that is written between Kafka and Elasticsearch?
So,
what is the responsibility
some
of that?
service, I don't know. It could do a couple of things. So somebody has to read messages from the Kafka and send to Elasticsearch.
Why can't Kafka directly put in the Elasticsearch, or can't it not put?
Sorry, I don't know if Kafka can directly put in Elasticsearch.
No, Kafka is just like the Kafka brokers won't run your custom code. So someone needs to read from Kafka and then persist it somewhere. So we could just have a component that just takes the dimensions like of the logs and then persist them in the appropriate table in the time series database, or just pushes them to Elasticsearch. That's fine as well.
Okay, so you need that some other service that reads that's a consumer of the Kafka and then persists in whatever persistence layer that we choose.
Yeah, we need a set of workers who listen to the Kafka partitions. This could be an auto-scaling group, and these workers, depending on how many logs are there, we can auto-scale them. And then these workers' job is to take the messages and then put them in the appropriate format and persist them in the underlying database or Elasticsearch.
The appropriate format we already handled, like the agent was handling in appropriate format, and do some kind of aggregation or whatever. So I'm just saying, are we okay? Are we not redoing things a couple of times? But I think that's fine.
Format would be different, right, for the logs and what Elasticsearch might expect.
Elasticsearch might expect a JSON object. That's it.
Yeah, and then the logs might not be JSON.
We can have structured logs, like the agent can handle to give a structured log, or that's not a. I feel that's not a breaking change here.
Right. So the Kafka will have some message with Kafka message related properties like timestamp and things like that. So someone needs to filter that log, make it into a JSON that we want to persist, only have the properties we want to persist.
I was wondering, the message in the thing is already JSON.
Yeah, message can be any kind of a message. Like a payload doesn't have to be JSON or any other particular format. It's just a message. So you can put JSON, you can put something else. If the Elasticsearch expects a JSON, then you will get a JSON format. I was thinking the responsibility for that service is just to fetch the Kafka message and then persist it in the Elasticsearch. Is that correct?
Yeah, and then transform it as well into the format that Elasticsearch understands, because we don't want to couple them. We don't want to say that, okay, these use the exact same format, because then we can't replace Elasticsearch with something else later.
Sure.
Okay.
At this point, we have not done any processing. We just persisted, right?
Yes, we have persisted. Yeah, kind of. We put that in Elasticsearch. So no monitoring has been done yet.
Got it.
Okay, so this part is kind of very high level. We haven't gone to depth in that, but this is a thing. And there's an alternate design also, which we can do here is in AWS, there is something like a fire hose. This is fire hose. If you send it to that, it has a direct integration with Elasticsearch. So it will directly can send also. But then if you want to do some kind of what Abhilash was mentioning, that transformations, that won't happen. So if we want a common, we want this and this to be separated, then we need somebody in between to do that part.
Sorry, what is that firehose part? I didn't get that.
So firehose is again think about a kind of a Kafka thing in AWS. Think like it's a Kinesis thing, but it could even broadcast data. Like the one you were asking in the start, can Kafka directly send to Elasticsearch?
Okay. Okay. Okay.
This is an AWS product, Firehose, Kinesis Firehose. It can directly send to Elasticsearch. We don't need anything in between.
Yeah, it's doing the same thing that our workers were doing. Our workers were taking data from Kafka and pushing them to, transforming them so the Elasticsearch can understand. And this Firehose is doing the same thing, where the source as Amazon Kinesis, and then the destination as Elasticsearch in AWS.
Mm-hmm. Okay. Okay, let's not go towards Elasticsearch, towards this guy, and we can skip it for now. Otherwise, it's become confusing. I just mentioned that point for just a broader understanding, like alternate things. Okay, now what? We have data here, and few other things we can take in Elasticsearch only, that retention period. But we are not yet there for our alarms and other things. How will aggregate or monitor or create a ticket or cut action?
Yeah, we need another service that knows the rules, has the rules cached in memory, and is able to like use the database we persisted in Elasticsearch to raise alerts, maybe push the alerts to a queue.
So my question is here. So that means I have to query Elasticsearch, right?
Yeah.
Is that very expensive?
I don't
No,
know.
it's pretty cheap.
No, but our Elasticsearch would be that good in that. I'm just trying to think.
Elasticsearch is optimized for search queries based on any dimensions.
But that search query, it is optimized. That part I got. I am just thinking of if the number of times that we query Elasticsearch, that will pose a slowness. Like we have to do this every second or every millisecond. It depends on the rules that you have. And if you try to query every millisecond for all the services that is coming for different rules that you have, is that going to be a bottleneck?
So, okay, before coming to that, I just want to take one step back. How this rule things will work. It looks like rule is kind of a cron job to me now. That has to be run after every periodic thing. Let's see what it will do, but it looks like it becomes like a job scheduler or a cron job.
I don't know whether it's a cron job. It's just telling that if a violation happens between X amount of time, then
Yes. So that means it should be running after that much time. So if I say in last 5 minutes, so it will check in last 5 minutes and then it should run after another 5 minutes, right?
That's a monitoring service which does that, right? Not the rules DB or rules service.
No, I'm not saying rule DB. I'm telling like whatever component is executing rule could be like a cron job kind of system, which based on the rule which are in the DB, it will scan once in a while and create kind of a cron job.
So if you have like 100 rules, we'll have 100 cron jobs running.
That's what I'm thinking.
So I want to pitch in here. So why not we can have some kind of a lambda or pattern matching here uh, instead of running multiple cron jobs. As soon as you get the data, you match with the expressions or pattern matching, which is nothing but rules. Based on the rules, it has been created. And if alarm is there, then send a notification. Does it make sense?
How often do you run the Lambda?
I'm not sure, to be honest. This is what came to my mind. Not Lambda or some kind of dynamic pattern generation, something like that we can think of.
Also,
Yeah,
right? Yeah, you can't get the live data and then pattern match the rule. My thought was like you need aggregation to say 70 times has it happened in the past 1 minute or 80 times that has it happened. A live data will give you one data point, but we need an aggregation of the past 1 minute of data to determine that there is a violation or there is no violation.
So for that, we can use like a stream processors like Spark or Flink, which will give exactly what Sri is asking.
So you're going, okay, I don't know about Spark, but does it like fetch the data from?
So you will attach it at the end of a Kafka, and as and when it reads a message from there, it will maintain its own counters inside. So let's say we are saying like our simple rule is if we see a particular error 100 times in a minute, fire an alarm. In that case, it will have a counter variable inside it, and it will keep on reading the stream of messages from Kafka and increasing its time as well as increasing its counter. And when the counter crosses that threshold, it will initiate an action or put a message into the queue. Okay, now fire an alarm.
So you're replacing everything after the Kafka part to the Elasticsearch with one Spark.
Yeah, the Spark cluster or the any Flink or something. Basically, these are distributed stream processors. they can maintain. I mean, I'm not saying replace everything, but I'm talking for the monitoring part. You can save them somewhere, but to process in real time, I'm suggesting that.
Yeah, I think I think that's another design approach. I think most for me, when I heard the initial problem statement, I think that was most applicable, either stream or Flink stream processing, which basically pattern match in real time and can maintain these counters, and then you can use that to basically monitor this.
So basically, we are kind of aggregating somewhere, right? Apart from Elasticsearch.
The Kafka I thought was aggregating, right? So once you're pushing onto Kafka, that's where all the data aggregation happens. Now the data is coming from Kafka is kind of serialized, and there you can actually, if you attach the stream processor like Flink or Storm, then you are applying those kind of like regular expression pattern matching kind of things at the serialized data, then which can maintain the counters. Then you use those counters to send the alarms.
No, but I need some aggregation also, right? Last 5 minutes or last 1 hour, something like that.
Yeah. So as I think some of the previous person explaining, these stream processors are actually also provide this kind of aggregation. They can tell you within last so and so time, this pattern matched for like 20 times, 30 times, like that.
So is it we're telling like we are giving entire responsibility to the stream processor, how it handles behind the scenes, use a DB or not? That is
right. So the stream processor specifically designed for something like this, on the fly data. It's basically certain things happened in this many number of times. The stream processors are pretty good at that, and they can do in the near real time.
But my question is then, interviewer could get an impression like this person is talking about a lot of technologies, but might not know in depth. Or so that means like we are telling service will send to Elasticsearch, the stream processor will do all thing, and we are done.
Yeah. So basically the matching. So once we have all the logs, right? The log data, if let's say line by line, right? Log is basically lines by line, and if each line, let's say there is specific pattern, correct? So if it is, let's say, an exception or alteration error, so those are all basically set of patterns, right? So if you turn all of these patterns as kind of filters in your stream processor, and then let's say for every alteration failure, there is a specific like the pipeline, the specific filter in your stream processor, and then it matches that, and then it can also maintain, you can implement these filters such that they can maintain over a period of time all the counters. So now all these information is maintained in your stream processor, and then then they can whenever the count reaches certain time, let's say certain number, let's say like 20 authentication failures, they can spit out an output which can be plugged to some kind of a logic to send alarm notification.
So whenever I have tried to tell a technology, like for example, a stream processor, or I can say, hey, I'm using some caching service like Redis or something like that. The next question usually I have faced is, so how does internally that service works? So when I say, hey, if I say stream processor, do you know how internally does it work? I don't know that always this will happen to all people, but usually that was the next question I always get asked, like how does it internally work? How does it aggregate internally? And that's why I'm hesitant to use like, hey, I will use a Spark, or I will. It's for me. It has happened that it's always a rabbit hole. Like I wouldn't know entire end to end how stream processor work, and I would get like stuck at that point.
So what I heard is basically two things. If you use a specific technology name, right? Let's say if you give an example of, let's say
I use Spark.
Yeah, Spark or Flink, right? I think in that case you should be really be able to answer internals. But if you generalize, let's say a stream processor, right? A batch processor, something like that. If you keep it a generic term, and I think as long as you explain that in a generic terms, I think you should be fine. Meaning as long as you know like how the stream processor works, right? Or batch processor works, or a mem cache, memory cache, I think that should be. But if you specify specific technology name by specific name, I think then you should be ready to answer those questions.
Is it okay for us to just identify how does this work without the Spark in this case, so that I also learn? Or we're just okay with using Spark, which will do all these processing, and I feel it does also alerting, or no?
Again, I could be wrong. I mean, if I'm being interviewed and if I don't know a specific technology in depth, but if I know principles well on a specific, for example, in this case, because real-time processing of data and pattern matching, I mean, the stream processor could be definitely used, and if you stick at that, right, the stream processor is basically in real time. You have basically it's like there's an input and there is an output, and it's a processing unit, right? And input, you're getting all these bunch of lines from your log, and then it does a pattern matching and spits out output. So if you if you at least be able to articulate that kind of solution, right, then I think it should be fine, in my opinion. Again, I could be wrong, and I want to hear if anyone has like a different opinion on this.
I just have a question regarding the stream processor. Like, let's say in last 5 minutes, I've got like 10 logs, and at 10 is the limit. And after, let's say, in the 6th minute, again I'm getting some 9 logs in first 5 minutes, and then in the 6th minute I'm getting the 10th log. Does it refresh itself, and then again it counts as a first log, or what happens?
Yes, stream processor will take care of all out of order or late events. It call it as a watermarking.
Okay.
Take care. So it's a one box solution and everything.
Okay.
Yeah, if for a system design interview, maybe it might work when you say that the output of Kafka is just fed to a service which just adds to a stream processor,
Right.
and the stream processor will take care of everything. I really don't know if that would be acceptable or not. It again depends on the interviewer.
Yeah, it's
and
more
how-
subjective and how confident you're telling.
Yeah, exactly.
I wouldn't definitely say it takes out everything. I think you should be able to articulate what it does, right?
See, I haven't used stream processor, so I don't have any. So it is something. It could be something based on today's interaction. I can go and say, "Oh, use stream processor," and then, "Oh God, what happened to me now?"
No. I would definitely. I think if at least if you don't know at least as principle level, right, how it works, I think.
Yeah. So that's the thing. So I know principles of Kafka, so I can talk at least 5 minutes over there. But okay, so I think the point which is a good point. Like, if you know principles, then it's good to bring in and be honest. Like, hey, I didn't work much on that, but I know how it works.
Yeah.
Like, this is a good candidate for this situation, but I'm open to talk about alternates also.
Yeah, so you had to remember one thing in these interviews, right? You are expected to solve a problem that worked on, right? I think that's what they're looking at you, right? How do you? Because most time, if you had worked on it, it's they assume you should be able to do it. I think this more of ambiguity. If you never worked on it, how do you solve it? So I think that's why it's not. You don't have to completely be expert in a technology and then use it. Even if you, that's why knowing the principles and applying them. I think, and honestly telling it, I never used it, but I know how the principles, how they work, and then I could apply that, right? I think that's I think that's a good way of approaching this.
But I think with principles, we should also know the pros and cons.
Yes.
Otherwise, and okay, again, it's subjective because it could be like you could be a SD1, 2, or a senior engineer or a principal. So expectations can vary across roles. So based on which role you are applying, I think then you have to pick things where if it's a principal engineer, the expectations would be high. Then just knowing the principles won't be enough. Then having a concrete idea like what are the pros and cons could be, because you have to guide the team. You have to like, okay, this, if you use this technology, you would be like finding these issues in like a month, 2 days, or something. Like, I think it could be subjective in terms of the role and experience and what things you're doing.
Right. I think, I mean, what is seen in the industry, right? So when they're hiring, at least in US, so either they are hiring you for, a specific experience and for a specific position project. So in that case, you are right, Asim, that you need to be able to articulate and experience, and you need to be able to know in and out. And the second thing is where they're hiring it's a general hire, right? That could go to any project, and they're more focused on your problem solving skills and how you put together a system. So if that's kind of interview, then the principles is okay. So it really depends on like really what job you being interviewed for.
Okay, so let's say we remove stream processor out of equation for now. I don't know, or somebody doesn't know what we can do now. Any comments or ideas?
So we need to convert the logs into metrics, because our rules DB will have rules based on metrics, not based on logs.
Mm-hmm.
So we
what
need
could
some
we
kind of
like
aggregation.
So we are doing like something like a system IO exception coming more than 10 times, or 400s are there for this much of time, then do something, right?
Right. So let's say we want to aggregate based on status code, and we have a rule saying that if status code is, let's say, 500 star, like starting with 500, it's server error, then raise some kind of alert. And it has a period of aggregation. Let's say in the last 5 minutes, if the number of 500s is greater than like 5, then yeah, raise this alert. So now this is based on metric, which is how many 500s occurred. Now the logs we are getting will have structured data, like where one of the columns would be status code. So we need someone to actually aggregate them based on status code. So that's where the stream processing comes in. So we could do this ourselves. Like what we could do is, like, before we are adding to Kafka, we know what kind of aggregations we want to perform, and based on that, we are we are separating logs into different partitions, and the partition key is based on the metric that we want to aggregate based on. So in this case, status code, I can say that values with status code this, like let's say status code underscore 500 is my partition key for Kafka, and all logs which correspond to the 500 status code are going to one partition. So they're going to be ordered messages within the partition, and there's going to be a worker listening. The worker knows that everything that's coming in this partition corresponds to 500 errors. It just simply aggregates them quickly. It doesn't need to worry or know about the logic.
So I had two questions in this. I like this approach. My question is, what happens if you have one more rule on the status IO? Say, for example, if you have 10 error messages in 400 millisecond, then throw an error. But we also have, if you have 20 system.io messages in the next 10 minutes, then a different alert should be sent. So you have multiple alerts on the same, I'm seeing that echo again. If you're seeing multiple alerts, multiple rules on the same status IO message, then would the same system work?
Yes, you can enqueue multiple messages for aggregation, right? So Kafka here, we are now using, in this approach, we are using Kafka for aggregation, for stream processing.
Not multiple messages. Multiple messages, I get that part. I'm telling multiple rules for the same set of messages.
Okay, so this component doesn't care about rules yet. Like, so let's say we have rules. So the rules part comes later. This component is basically independent. It doesn't know about the rules at all. It just knows that it needs to aggregate based on these kind of dimensions. And based on the dimensions, it enqueues it to an appropriate partition in Kafka. So we have all sorts of different aggregations. So whenever you're defining like what sort of metrics I want, you are also defining what sort of pre-aggregations you need. So you already define that, okay, if I need my status code metric, then it is already aggregated by my cluster name, node name, pod name, and so on. So you define the pre-aggregations beforehand. So these pre-aggregations is what this component cares about. It doesn't care about if there are 10 or 1,000 different rules configured on different metrics.
Yeah.
I like this part, except when there is a compound rule, like I need say system.io and something other IO, then those are in two different shards now, and maybe that will work. Maybe it won't. I don't know what that answer, but I like your partitioning based on system.io or whatever is the exception header. That's the one that you're using as a partition key. What happens if there's a compound rule having compound exceptions? That's the part now I'm because now I have to look for all the different shards to identify whether both of the conditions satisfy.
So is it what you're telling, like we'll scan the rules and create partitions based on the rules?
No, so the rules are independent. Like, so the system which is processing and aggregating data doesn't know about the rules. Now, the system knows about what kind of pre-aggregations has the user defined. So whenever you're defining metrics, you also define what kind of pre-aggregations would help you perform that query faster. So when you're defining, as I mentioned, the status code metric, you already define that, okay, I would want to segment this status code by node name, cluster name, pod name. Then I already defined that pre-aggregation. So this pre-aggregation data is separate from the rules, and it's also stored in a database. And that data is what is used by the aggregation system. It knows that I need to aggregate these logs based on these dimensions, and then it does the pre-aggregation, and that pre-aggregated data is persisted. Now, whoever knows the rules basically queries the pre-aggregated data. It doesn't have the full log data. It queries the pre-aggregated data, and it's much faster because what it needed is already pre-computed.
Is that a prerequisite? Because it's not mentioned in the requirements. Like
that's how metrics and logging systems work.
Yeah, because it's gonna take off a lot of load from the system, right? If we are seeing like within last 1 second we have like 1,500,000 for a particular client, 500 errors. So this pre-aggregate will zip that everything into a one message saying in this second we saw 500. So the processing has to just read one message and it has got all the info. So I think that's advantageous. It will reduce the scale to a very manageable level.
Yeah, that is absolutely correct. It will reduce the because we're only looking at the pre-aggregated data, not the entire data that is being sent by the client. My question is, like, at the time of creation of that rules, you wouldn't know what is your pre-aggregation logic. Just providing, right?
So basically, what if I have to just separate this two things? Like, see, I think we are going more towards now metrics. So when the matrix is there, we have to initially define what would be the what is that? What all things or dimensions I will take care. So pretty much, I think it's a standard input you can provide. Like this would be metric, this would be this would be that, and then I think we can do lot of pre-computations. But if my logs are quite unstructured, where I don't know what user could send, then I don't know what we would be doing.
Yeah, I was thinking of like from wherever you have put your data, that is from what you drew earlier, the Kafka putting into a time series Elasticsearch, you would just read the last X timestamp of data, and then you will apply the rules. Every second, the service will just read the X rows of data. That X rows of data will be by timestamp. So give me the last 100 millisecond of data, and then it will just apply the rules. That was what I was thinking. But
Yes,
I like
and that is one design. So I think we are going more deep into that, like how then it comes to like how every time we have to read last 5 minutes. What if I start aggregating and then I don't have to go and query last 1 hour? So yeah, so I think that's what we are going towards that.
Yeah, during the aggregation, the accuracy is going to take a hit, right? Because if say you are aggregating every 1 second, and then we have to aggregate on last like 60 seconds, we may or may not have the exact, because you are doing an average of an average, right? So the DB part is gonna be very accurate, but this aggregation is little bit an hit on the accuracy.
Oh, you're telling like it could problem when we decide how to collaborate data. Like I'm telling like all 1 second data is one entity and then taking average out of it.
Yeah. So in that case, we might be a little bit off, right? Every time, because we have already aggregated, and then the query is like, if you want to aggregate on an hour or so.
It depends on the aggregator function. Like if you have a function like max or min, it doesn't really matter if you have the individual data points available. For average, yes, they are required, and I know some companies have specific specific aggregation logic just for average, because average needs sum and the count, like 2 parameters to actually compute. So in general, like whenever we onboard a new metric or a new alert, the best practice is to make sure a pre-aggregation is already defined. Otherwise, that query would be not scalable.
So, can you, Abhilash, do you know on top of your head any example of such system which widely used by corporates like Splunk or something? Do you know? New Relic or like, I just want to know generalize or correlate so audience can think like in a real interview what they can mention about.
Right. So pretty much every system is based like on alerts defined on metrics. Like because logs, I mean, how do you define a rule on a log?
So you mean like when we define a rule, it's kind of a pre kind of we are setting something like this would be my metric and this would be the things I would be looking for.
Right. So log would have a lot of key value pairs, right? Now, if you want to set a rule, like you might have to define a query, like for logs, right? So, and after that query, you will run that query on the logs and then get some kind of result. That result is called metric. You ran some computation and you aggregated the logs. Let's say you extracted the status code as 400, and you assign a value of 1 for every log that has 400 status code, and for every log that has status code different than 400, you assigned a value of 0. And now you're aggregating this column of 1 and 0 to count the number of 400. So this is how the aggregation works, right? So this part, the additional column we added with ones and zeros to be able to compute the aggregate is metric. So we convert the logs to metrics, and then the rules are based on the metrics.
Okay.
But that aggregator has to be like, it has to read from the logs DB or wherever we're storing every minute or every second or something like that, right? So that it can
So
aggregate.
we can do real-time aggregation as well. The aggregator knows what dimensions it cares about. So let's say I have a dimension called region in the logs. So it's a key value pair. Let's say region is East US1, West US2, or so on. And the aggregator knows that a predefined aggregation exists on the region dimension. So any log, any structured log that's coming, it's going to say that it's going to maintain a separate partition. It's going to use region as the partition key, let's say US East 1, and it push that message to a specific partition within Kafka. And now there's a worker who's listening to this partition. It knows that every message in this partition corresponds to US West 1 or whatever region it corresponds to. And then it just simply aggregates those logs. And then we can have lots of different kinds of aggregations defined with multiple dimensions. We can have a region, node, cluster, let's say 3 dimensions defined. Then it's going to do the aggregation for every each of the dimensions. So now when a rule is defined and it finds the data already pre-aggregated, now this rule is much more scalable and can run much more frequently. Otherwise, if I'm computing a rule, I do not have a pre-aggregation, like it might take a long time and it's going to be expensive query.
So I see your point. The way I am understanding is you're telling there is a, like this Kafka will write to this DB all the logs. You can have another consumer, which is based on US East Coast example that you said, that will aggregate all the logs that is coming from Kafka, and have the rule. Now that will be a metric, and that will be stored somewhere, and this rule will be run against those metrics. Is that
right? So the logs would be persisted as is. So we still have the full logs, but now we also have the pre-aggregated metrics, and then the rules will be applied on just pre-aggregated metrics, not on the logs, because there could be like billions of logs. Like each rule won't actually query on those billions of logs, right?
Yeah, makes sense. Where do you store those metrics then? Is that in a DB or is it somewhere else so that you can then run those rules against those metrics?
So those metrics could be persisted in a database, and then we could also cache them in memory, because we need to use them frequently, especially the metrics computed in the last, let's say, 1 day or like whatever time period is suitable for the application.
That will be small enough to be fit in in, like, for example, Redis. I'm throwing a cache out of the box, but say, for example, Redis, if I use, will that be small enough that I can put it in Redis?
I mean, it depends on your configurations, right? So where the backend configurations would determine how much metrics are stored and what logic is used for removing old metrics from the memory.
I see.
We could cap the size to, let's say, XMB, and then like whatever are the older logs, they would start getting truncated. So we'll first look if we have those metrics in memory for that time range. If not, then we look up into the time series database.
Okay, so let's, for one example, say I have a rule which says that if my latency is less than 1 millisecond for the past 5 minutes, throw a alert. If that is the case, some agent will be sending this as a log. In this case, some agent, I don't know what the agent is, but it reaches your SVC service. I'm looking at the diagram that is drawn here. And then that latency, every millisecond one record is coming. So it goes to Kafka. Kafka writes that into the SVC that is drawn here, and that goes into a log stash, in this case, the Elasticsearch. There is another consumer for the Kafka, which gets that message also, and it just adds it into one, like it aggregates how many times I have seen the response that is coming that is less than 1 millisecond, and after 5 and puts it into some cache. Another service reads from that cache the aggregated metrics and then determines whether it is breaking the rule or not breaking the rule. And you just, if it breaks the rule, do the appropriate action. Otherwise, it just leaves whatever is the cache there and then goes away. Is that the overall thing that you are telling?
A couple pieces are like that. So basically, in the logs, you get some latency numbers, like latency in milliseconds. Let's say you have a latency column, which is saying, let's say 300, and you want to alert on if the latency is, let's say, greater than 500, you want to alert on that. So some component needs to understand that it's a integer value. So and so this millisecond number, it's a gauge. Like when you're aggregating it, you won't actually so you won't use a counter for this. Like for 400s, you can use a counter as a counter metric, but this is a different kind of metric. This is the gauge, so there would be different kinds of aggregation for this one. So in this one, the aggregation, you just want to persist that database, and you can maybe say max, min, or average. You can persist those kind of aggregations in the time series database. And when you are actually querying based on the rules, when you are evaluating a rule based on the frequency set for the rule, you look at this aggregated metrics, which already have the aggregations you predefined. So let's say you are interested in average over a period of time or max over a period of time. So this data is already available. And Elasticsearch would be used to actually just perform queries. Like if you want to run random queries, Elasticsearch could be used, but it won't help in this case. Like in this case, I would need a time series database where I can perform these kind of queries over the metrics aggregations over a time period. Like, so if I have a rule that runs every 5 minutes over last 10-minute data, so it will perform a query over that 10-minute data, get the pre-aggregated metrics, and then aggregate those records that it got and return the result.
So in either case, you need a logs DB and you need a metrics DB for aggregation, for storing the aggregation and storing the raw logs.
Right. Yeah. So in this case, we need the full logs as well, right? So yes, we also possess the original logs for 14 days. But now the metric data we can persist for a different time duration. So let's say if we are only concerned about like operational metrics for last 1 week, then yeah, we can store just 1 week data.
I mean, considering the metrics, DB has to be like much less in size than the raw logs. And
right.
retention period, I'm not worried about. It's going to be much smaller than the original log size as well.
Right.
But the basic tenant here is you are bifurcating between like a logs DB that is used for searching logs, and you have a metrics DB which aggregates as and when the result comes. But I'm just thinking whether you're duplicating data at any point of time.
So it's just like original logs and pre-aggregates. So there's no duplicate. And like in case you do need the full logs, then yeah, you need to have those full logs separately from aggregates.
So at any point of time, you're not even looking at the raw logs for aggregation. You're only for checking the rules. You're just telling the rules to only look at the metrics DB for determining whether there is a violation or not.
So this, I think now in terms of became like a full-fledged monitoring system. So having a logs persist is a good to have. But if you want to combine both of it together, like all the requirements which we thought, analyze, monitor logs, rule sections, store logs, view logs, then it becomes a full-fledged package.
Yeah. And we didn't use Spark at all.
Oh, which one?
And we didn't use Spark at all.
Yeah.
So we might need Spark depending on the scale of the logs, right? If there are like the billions of logs being generated per hour, then we do need some either Spark or some other alternative to actually aggregate that data. So and then I'm guessing we won't persist everything. We won't persist all the logs in that case.
Yeah. So basically, we need something like a map reduce kind of thing here, where you can do some kind of a parallelization.
Map reduce is batch processing, right? That is not for real time, isn't it? My understanding.
So I think Spark can do real time. That's what, like, it's an in-memory operations. That's what I know.
Yeah, right. Not truly real time. Like it has a micro batch. It will do everything in a batch of 1 second.
Or could say batch processing.
So actually, even Kafka has the real-time processing, right? The stream processing, Kafka also has a capability.
I don't know about stream processing Kafka.
What is, it has the capability, but processing means what processing? Is it like, can you define that?
So whatever I think queries that you are hitting on the metrics DB to get the counts and all, you can hit on the Kafka topics. So with those new capability that they have, they call KSQL DB. You can write SQLs.
Yeah, that's true. Yeah, that's true. Yeah, we are using KSQL in some part of my company, but I also heard that you can use for real time. But I don't know whether that is used for like a monitoring system kind of situation. Maybe it can be used. I have no clue.
It could be used for constructing dashboards, right? Or maybe just like if the on-call person wants to get some data about some, let's say, hosts, what are the CPU and the memory metrics. So depending on the range, we could combine data that we persisted in the pre-aggregates and the data in the Kafka topic, which is still yet to be processed. We can combine the results from both and like still serve the real-time query.
Yeah. So this system which reads from the aggregation DB, it also needs to send an alert, right? That is like another system which will be an alerting system, or like alerting service which will get the violations from the monitoring service and then sends the violations or sends the alerts. That will be another system here.
Yeah, it could be like the cron job that Asim described. So we already have the frequency of the rules along with the attributes, and the cron job runs and then uses the pre-aggregate to actually compute the result of whether to raise an alert or not.
Yeah, that part I don't know whether you want to have like if you have like 100 rules and you have 100 cron jobs. I thought you have one service which keeps tracks of the rules and queries it every
So
second.
when service will wake up, it has to sequentially go through 100 rules.
Yes, I was thinking the service never sleeps in the first place. You just query it every second. The monitoring.
Yeah, that would be batch processing system. Because then some rules might have to wait before other rules are evaluated if there's a single service handling. With the cron job thing, like you have you know the exact time when you want to actually evaluate the rule, and it's easy to just like schedule like multiple parallel workers. Like if there are multiple cron jobs that need to be evaluated at the same time.
But then who monitors those cron jobs? What happens if those cron job fails? Like what happens if there is no resources for a system to schedule? What happens? Who monitors it at that point?
It's the same as we would monitor it if it was not a cron job. Like we have logs, and then we based on logs from that service, we'll know if it's working.
So what I was thinking, like we can have something, we can say like there could be another system which we don't own, or a sister team can own, where you submit a job and that's it. You tell like, okay, after every 5 minutes, do this thing, like go to this DB, pull the data and do this, and be done. It could be like a script or something. So I'm just throwing some ideas, like the system would. Mm-hmm.
One other thing I had was like you put like a priority queue based on the time of frequency of jobs, and then you just pop out every time the time has like 5 seconds will be coming first, and then 5 minutes will be coming after that, and then 5 hours will be coming after that. So then you just pop off the first element from the queue, and then you apply the job and then re-enqueue of that thing after, so that when you re-enqueue again, the 5 seconds comes in the front. And when there is when the 5 minutes matches the 5 second after like 60 times, then both the jobs comes out. That's what I was thinking.
Yeah, that's the cron job scheduler design, right? So that's a separate design problem altogether. And there are different ways of doing it.
Okay, I think we are almost at the time now.
Yeah.
And but I really like today's discussion where it was not an easy problem. It's a tricky and complicated problem, and then everybody chimed in, shared their experience and thoughts, and that's what I think we're expecting as a group to move forward.
Yeah, I definitely learned a lot. Yeah, thank you so much for helping me.
Yeah, I'm stopping the recording now.